Hello everyone. So this is our lecture number 5.3, and in this video our topic is solution of exact differential equation. In my last lecture we have learned what is order and degree. Also we have learned what is exact differential equation. Okay, and in this video our topic is how to solve solution of exact differential equation. Okay, this is our topic. Okay, let me tell you exact differential equation. That means if the equation is m dx plus n dy, this is equals to 0, then it will satisfy the condition del m del y equals to del n del x. This is called the condition of exactness. Yes. Okay, now let's solve a problem. Okay, before that let me tell you that if the equation is not exact equation, then you cannot solve the equation. So first of all, the equation must be exact. Okay, then you can solve the equation. Okay, so what is the process? Suppose you have an equation m dx plus n dy equals to 0. So obviously you don't know this equation is exact equation or not. So first step is you have to verify this equation is exact or not. Okay, so first step is check exactness. Okay, this is your first step. Second step is you have to find out the solution, and directly you have to use this formula. What is the formula? Integration m dx plus integration terms of n free from x dy equals to integrating constant c. Okay, so this is your given equation m dx plus n dy equals to 0. Obviously here the first part is integration m dx, and you know what is m? This is the coefficient of dx, m. So obviously you can integrate this portion. Let me explain you this part. Terms of n free from x. What do you mean by terms of n free from x? Let's say I am taking any arbitrary example. Let's say n is equals to xy. Okay, and in another example, let's say n is equals to x plus y. Okay, it is saying that terms of n free from x. That means you cannot take the variable x, only you have to take the variable y. But in this expression xy, you cannot separate the value x from y because this is in product form. But in this expression x plus y, you can separate the value of x. How? Because if I write this is x plus y dy, yes or no, just I am calculating this portion. Okay, so x plus y dy, so this is equal to integration x dy plus integration y dy. Okay, and it is condition is terms of n free from x, so you cannot take the x variable, so you have to neglect this portion, only you have to take this part. Okay, so if n is equals to x plus y, so in this place you have to write just integration y dy. Okay, and if n equals to xy, so obviously you cannot neglect the term x, so in this case you have to write 0 dy. Clear? This is the concept. Now after solving the integration, you will get the solution. Let's understand using an example. Question. Solve e to the power x sin y dx plus e to the power x plus 1 cos of y dy, this is equals to 0. You have to find out the solution. Okay, so first of all we have to check this equation is exact equation or not. So solution. So here m is equals to e to the power x sin y, and n is equals to e to the power x plus 1 cos of y. Okay, so what will be del m del y? Del m del y equals to, del m del y, that means partial derivative with respect to y. So all other variable except y, that will be considered as constant. So that means here e to the power x, this is our constant. So the derivative will be derivative with respect to y. So this will be e to the power x cos of y. Okay, and del n del x, this is equals to, actually e to the power x plus 1 cos y, we can write this is e to the power x cos y plus cos y. Yes, so this is equals to derivative with respect to x. Here this is cos y, there is no term of x, so this portion will be 0. Only you have to derive this portion, and with respect to x, so derivative of e to the power x is e to the power x, and cos y will be treated as constant, so this will be e to the power x cos y. Clear? So here, so del m del y, this is equals to del n del x, and this imply the equation is exact equation. Okay, now you have to solve the equation. So now integration m dx, formula is integration m dx plus integration terms of n free from x into dy, this is equals to c. C is integrating constant. Okay, so or integration m dx, m means e to the power x sin y dx plus integration terms of n free from x. Okay, what is n? This is our n, e to the power x plus 1 cos y. Okay, or you can say e to the power x cos y plus cos y, and you can see in this expression, this part e to the power x cos y, it is including the variable x, and you cannot separate the variable x because this is in multiplication form. Okay, but in this expression there is no variable of x, so you have to write only cos y. Okay, so cos y dy. Clear? Okay, and this is equals to c. Now just integration. So or first integration is with respect to x, so sin y will be constant, so this will be e to the power x sin y plus, here the integration is with respect to y, and integration of cos y is sin y, this is equals to c. So what is the answer? E to the power x plus 1 into sin y equals to c. This is the answer, and c is integrating constant. Okay, this is the solution. Let's solve another problem. Question. The equation is solve 1 plus 6y square minus 3x square y dy dx, this is equals to 3xy square minus x square. Solution. Here you can see that this equation is not in the form m dx plus n dy. Yes, so first you have to convert this equation into m dx plus n dy form. Okay, so you can write 1 plus 6y square minus 3x square y dy dx, this is equals to 3xy square minus x square. Okay, now you can write from here that 1 plus 6y square minus 3x square y dy, this is equals to 3xy square minus x square dx. Okay, or you can write, you have to write in the form m dx plus n dy, this is equals to 0 in this form. So from here 3xy square minus x square dx minus 1 plus 6y square minus 3x square y dy, this is equals to 0. Clear? So now what is m? M is equals to 3xy square minus x square. And what is n? N is equals to minus 1 plus 6y square minus 3x square y. So let's calculate del m del y. This is equals to, derivative with respect to y, so this will be 2y, so 6xy. Okay, and here there is no expression of y, so this is 0. Now del n del x, derivative with respect to x, so this part will be 0, this is 1. There is no term of x in 6y square, so this is 0. So from here you are getting derivative with respect to x, so this will be minus 6xy, and here again you have another minus, so minus minus plus 6xy. So here del m del y, this is equals to del n del x. That means the equation is, this implies the equation is exact equation. Okay, so now we have to solve the equation. So integration m dx, what is m? This is our m. Okay, so 3x y square minus x square dx plus integration terms of n free from x. Okay, terms of n free from x bracket. Okay, so you can take this one, you can take this 6y square, but you cannot take this part 3x square y, because here you are getting x variable and this is in multiplication form, so you cannot take this part. So only you have to take 1 plus 6y square. Okay, and here you have a negative sign, so also you have to take this part. So minus 1 plus 6y square dy, this is equals to c. So or okay, integration with respect to x, so this will be 3x square y square divided by 2 minus x cube by 3. This minus is out, so this will be integration with respect to y, so this will be y minus 6y cube by 3, that means 2y cube, this is equals to c. So what is the final answer? Actually you can simplify this part, or you cannot, you may not simplify this part. I am simplifying, so the LCM will be 6. Okay, so 9x square minus x square y square minus 2x cube minus 6y minus 12y cube, this is equals to c. Okay, actually this will be 6 into c, and you can write this is equals to c dash. Actually since c is arbitrary constants, so you need not to write this portion, just write only c. Okay, does not matter, and this is your answer. Let's write c is integrating constant. Clear? So in this way you can solve exact differential equation. Very simple and very easy. Okay, and definitely you will get at least one question from this exact solution portion. Okay, now my question is, if the equation is exact equation, then obviously you can solve this equation. But if the equation is not exact equation, then how you can solve this equation, how you can solve the problem? Then first you have to convert the non-exact equation, you have to convert the non-exact equation to exact equation. Okay, if the equation is not exact equation, then the solution method is, first you have to convert the non-exact equation to exact equation, because I already have told you that if the equation is not exact equation, then you cannot solve the problem. Okay, so this is your first step. You have to convert it into exact equation. Now question is how you can convert this equation in exact, and here this is our most important topic. This is integrating factor. Integrating factor, and I will discuss this topic in my next lecture. Thank you so much.